Thank you so much for joining us today. Hello, everyone. Welcome to Intro to Data Science workshop here at Flatiron School. My name is Patricia Rodriguez. I am the events manager here. We're super excited to have you guys join us this afternoon. Today, we're joined by Daniel, who is a data science instructor here at Flatiron School, who is just going to walk us through this wonderful workshop where you will get the chance to build a recipe recommendation system, which I'm really excited about. So I'm just going to pass it along to him, and yeah, enjoy, guys.
Awesome. Thank you, Patricia. I've thrown into the chat there in Zoom a link to what you'll see on my screen here. This is a template repository. If you're familiar with GitHub, this is public. You are welcome to go ahead and use this template and to create your own repo. If you've got a GitHub account, this is how you might be able to follow along. I've provided the necessary data we're going to use for what's really sort of a search-based system with some minor recommendations at the end, what we call content recommendations. I'll talk a little bit more when we get there. But just to kind of start us off, I'm going to quickly hop over to share something else after this. But I've got necessary files here to set up. In particular, setting up what we call the environment within data science. If you're not sure what this is, that is okay. Essentially, this is dictating the requirements we need to run certain code. I need access to certain packages. In particular, for this demonstration here, we're going to be utilizing something called Streamlit, an organization, an app program called Streamlit that is actually going to allow us to write Python in a Python file and actually code up what a web-based interface might look like. Have an app that can be live if we deploy it via Streamlit. There's some constraints there, given that we're using a free system here, right? There's some limits in terms of how much we can deploy, right? In terms of memory and usage. We'll talk about that when we get there as well. But we need to have this set up essentially in our environment. I've provided some instructions here if you're familiar with Anaconda. This isn't something we really step through today. So again, don't worry if you aren't familiar here, you're welcome to just follow along with what I'm doing. But you do have a repo here available if you want to get started. And then as a way to download data, I've also provided the 3 cleaned data files we're going to use. So our first step today is actually to jump into what we call a Jupyter notebook. And I'm going to do this in a different interface here on where I've actually done some pre-processing on the data so that we can use it in our Streamlit app to form this recipe search recommendation. The idea here for today is to, right, can we create a little app where someone could enter some ingredients, right? Let's say you've got some ingredients in your fridge. We've got some tags, right? Recipe tags. Some very high-level general information about recipes. Maybe you want to select some tags. And from there, right, it's going to return you some good recipes that match your selections. And then also, right, you can pick through those selections, find one you really like, get access to the actual recipe itself. I've got a link we can pop up. And then also provide some recommendations, what we call content recommendations or similarity recommendations. You liked this recipe? Well, here's some other recipes that maybe not similar in terms of ingredients, maybe similar in terms of ingredients. We'll take a look at all of the information that goes into creating that similarity. So I'm actually going to hop over here really quick to my terminal, where I have this repository. If you'll notice, I've got my required files here that live inside of this GitHub. So I've just brought this down to my local computer so that I can work with it here. The first thing we want to do is I'm going to follow those instructions on that recipe page. So just in case you are following along, you can get an idea of creating this environment. And this is really important, not just for data science, but really for coding and programming in general, so that someone can reproduce what you're doing with code. Hence why we're providing what we call this requirements.txt file. You'll see it here in my file system. This is that file that contains all of that really good, juicy information about what packages I need. So I'm actually going to use Anaconda, which is a package file manager here. It's a lot more than that, but in that case, this is what we're using for. Now I'm going to go ahead and create what we call a new environment. And I'm going to give it something called pip. Pip is another package manager that Streamlit uses to set up its environments. So Streamlit uses it. We want to use Streamlit. We've got to conform with that. This is going to do some thinking for me. It's going to give me some prompts. What we are doing essentially here is downloading and extracting or installing these necessary files into this very particular, what we call an environment. And we talk all about this in the Flatiron Data Science program. It's one of the first things we teach. Day 1 and 2 is all about setting up your environment. Even some of the pre-work is all about setting up your code environment. I do need to go ahead and activate it. You'll notice it shows up in blue here on my left side. And I've got one more step here. We need to actually use that file to install these requirements. Now, this is going to take a moment. Not too bad. And this isn't a big one. I've tried to slim this environment down as much as possible. Again, the idea is we only want to use what we need to use. Right? We don't want to have anything extraneous, anything I'm not using. There's a couple things in this environment that'll go beyond today's lecture, because I want to try and take this demo, this project, to the next step. There's a couple different levels we can bring it to after the fact. Perfect. Looks like everything worked. It would tell us if it didn't. And now we're good to go ahead and jump into that notebook I was talking about first. And I've got some code already in there for us. Once we look at that, we're actually going to jump to a Python file and write some Python code to spin up Streamlit. So I'm going to open this up and then share my screen with y'all. Just give me 1 second here. I promise. And if you need me to make text bigger or anything, just let me know in chat, and I can zoom in a little bit if necessary. So really quick, before we hop to Streamlit and actually trying to create this app with Python code, we need to think about our data. This is data science after all. Data science covers a lot of things, including recommendation systems, right? If you think Netflix, if you think, if you've got some news aggregate and you're getting news articles recommended, scientific paper recommendations, if you're on any kind of e-commerce website, right? Chances are, whether it's clothes or music or movies, chances are they have some kind of recommendation system for you. We're going to talk about the first kind of recommendations called content-based. We also have something called collaborative, where we use user interactions to form recommendations. This is the slightly more advanced. This gets into machine learning and actual data science modeling. And this gets into artificial intelligence. We're not going to cover that here. This is some of the stuff that we talk about later on in the data science course at Flatiron, phase 3 and phase 4, right towards the end. This is the more advanced machine learning, actually spitting up a prediction. Can we predict how you might rate a certain piece of content? What we're going to do is talk about similarity. You like this recipe in this case, right? We're going to look at food recipes. Well, if you like this, here's a recipe that's similar in some manner. We'll talk about the features that can go into that, because we've got a lot of choice and decision there. Well, okay, you like this. Here's 5 things that are similar to it. Chances are you're probably going to like those as well. So we can think about this really sort of, I say simple, but it's not always super simple, content recommendation, or just a similarity comparison. And we're actually going to use a cosine angle to measure that similarity. We can use some mathematical properties of vectors to, this cosine math function, if you're familiar, to actually determine how close things are to each other, right? How similar they are. If I've got 2 recipes and they form 2 vectors, and those vectors are really close to each other, a vector just being a line with a certain direction, right? We know that they're really similar. They're very similar vectors. And we can measure the angle using cosine between those 2 to get a measure of, right, how close they actually are. So data science uses a lot of math. A lot of people always ask, especially coming to the Flatiron program, right? What's the biggest thing I should study before starting? And if I wanted to get just into data science, what's the first thing I should look at? And I would say, college level math, some algebra, just a little bit of calculus. You don't need to go too deep, right, into hypothetical math and theoretical math, but you need to know some of the basics in order to run statistics, in order to run some basic descriptions and summaries, as well as trying to understand that how we measure these different principles, things like similarity. So we're going to step through Notebook here. I do need to select this environment we chose. And I'm going to run through this quick before we jump to, again, Streamlit Python. I'm going ahead and importing my modules or libraries. This is what we installed with that file. The biggest one here I'm going to highlight is something called pandas. This is a data scientist's best friend, especially when you're first starting out. It's pretty easy to use in that it's got very clear documentation and syntax. And this is going to allow us to manipulate tabular data, right? If you think of Excel file, data that's in a table, it's got rows, it's got columns, right? Those columns have headers, and then filling in all that information is the actual data itself, right? For each row, we've got some data for each columns. In this case, right, we'll take a look really quickly here at our recipes data. Each row is a single recipe, and we have some really good information about that we can use to search, and we can also use for some similarity comparisons. So I'm going to use pandas here to load in data. Now, as a data scientist, you don't need to use pandas, but all of these different libraries, these different imports, make our lives that much easier. I don't have to actually calculate cosine, because we could do that, right? We could come up with the actual formula. Well, we have something that does that for us, right? It's already existed. It already has been coded up. We're going to use that. We don't need to reinvent the wheel. You see this all the time in coding in general, but especially with Python. It's very open source. It is open source. And one of the benefits there is that there's a plethora of these third-party libraries, packages, use that word kind of interchangeably, that we can utilize, access, install, and import, right? Things that have already been developed that help us out and, again, increase our efficiencies. So I'm going to go ahead and load in some data here, and we're just going to take a look at it. We're going to take a look at the first 5 rows with what we call a dot head. And you'll see that each row is a recipe. We've got the name of the recipe. That's some good information. We'll probably want to keep that. We have the ID of the recipe. We definitely want that. And that's how we're going to distinguish the specific unique recipes. We've got the minutes it takes. We have who submitted it to the website. We're running off recipes from food.com. We're actually going to create links back to them. Oh, okay. Looks like chat isn't quite working. We'll see if we can get that working. We've got some tags. This is going to be pretty good information, right? We could maybe use this to filter different recipes. Do you want 60 minutes or less, or do you want 30 minutes or less? And we've got a lot of different tags. We'll explore some of those in just a little bit. We've got some nutrition information. That's also really great. That's good to know. I'll talk about the order that this shows up in, right? You'll see here we have just a bunch of numbers related to different nutrition metrics. We've got the number of steps, right? We have the actual steps themselves. We've got a description of the recipe. We've got our ingredients and our number of ingredients. Now, just want to highlight, right? We've got different formats here, different structures of data. And this is what data cleaning, data pre-processing, data preparing is all about. Right, figuring out what you do have and what you need it to be. Right, I have all these tags stored as what we call a list in Python, denoted by my square brackets here. And you'll notice, right, we've got another list, we've got a list of steps. These are a list of steps, right, with text. Here we have a list with numbers. Here we have text as well, right? Notice the quotes. So if I want to look at all my steps, right, I need to think about how I can break out this list. I've got a data structure that I might need to transform into a different data structure. What a lot of pre-processing is. This is something we call ETL, or extract, transform, and load. You'll hear that acronym very common if you start digging into data science. You might also hear something called exploratory data analysis, EDA. The idea there is, again, right, well, what do we have? What are we working with? What can we do with it? What do we want to do with it? Right, in this case, we need to think about how we can compare recipes. Well, we can compare them based on, just how long it takes. We can compare them based on some of the specific tags, right? All of our 60 minutes or less recipes are similar to each other. All of our 30-minute or less are similar to each other in some manner. We could compare via nutrition if we break these values out, right? And other things like number of steps, the actual steps themselves. This is going to be a bit advanced. We'll talk about why we probably won't use that today. Maybe description, maybe not, but definitely the ingredients, right? That's probably one of the biggest things we want to use to compare recipes, right? similar recipes with similar ingredients, right? If you liked this recipe that used all of these, 7 ingredients, you're probably going to like this other one as well. No guarantee, but right, we can make a pretty good assumption. And then we just have number ingredients. Again, right, we could use that as well. So we've got some really good information here. Something I like to do is every time I look at data, I run a .head. Look at the first 5 rows. Again, right, just a sneak peek of what kind of information we have. Also run a .info. This gives us a very good summary of, right, how many recipes we have. So like just over 230,000, quite a lot. We've got all of our columns here. We've got some null information, right? We have a little bit of data missing, right? Null data that wasn't filled out or didn't exist, right? Doesn't exist. We do need to handle that, obviously. That's a very big key part of EDA and ETL within data science. What do you do with null data? You'll notice we only have a little bit. We'll explore this a little bit more in depth in just a second. I also like to look at some statistics. This doesn't do much for us here. We don't have too many numerical variables to run a general statistics on, right? Mean, median, min, mode. We can get our objects as well, but again, the format of our data doesn't lend too much here. But we can look at our nulls. Right, we notice that we have about 5,000 nulls in our description column and 1 missing name out of 230. Well, that's 230,000. Right, that's pretty good, actually. In fact, that's really good. This isn't that dirty. You'll hear the word dirty data all the time because that's just how it is in the real world. Data is dirty and you've got to clean it. Well, I'm only missing about 5,000, again, out of the 230. That's a very small percentage. I need, or at least I want, the description, because I actually want to return that, right? When we start producing recommendations and we start producing recipes that we think someone would like, we need to think about what we want to give them, what information about that recipe we want to give. Well, the description can be a really good, simple, for lack of a better word, right, description about that recipe. So I kind of want to keep that. I can't fill in these 5,000 values. That's something you can do sometimes with null data. We talk a lot about that in the data science course in phase 2. But I can't really do that with description, certainly not with the text we have here. So we're just going to drop these rows. And we're going to drop the 1 row that has a missing name as well, right? Because we want the name of the recipe too. Again, that provides some context. So I can drop my nulls really easily. If you notice, we drop this data, and now all of a sudden, right, I don't have those 5,000 rows. I dropped those rows, any rows where that data was missing. This is the sort of most straightforward approach to handling null values, right? If you think you can get away with it, you've got enough data already. Again, right, 5,000 out of 230,000 is a very small percentage. We can justify getting rid of those recipes. Well, now that we've done just a little bit of null processing, we're going to think about our different columns here. Sorry for the scrolling, right? But let's think about our tags, because that's going to be very relevant, again, for our similarity, right? What kind of tags do we have? Now, it comes in as a special format. I'm not going to highlight this too much. This is just the way that the data was actually formatted and given to us. It's actually a string representation of a dictionary. So I'm forcing it back into a dictionary so that I can explode that list, not dictionary. That list out is what the .explode is doing. Right? It's taking all of my tags. It's going to take a second here. It's taking all of my tags for every entry, right? 0, 0, 0, 0, my first row, and all of its tags. So it's just putting these all out for us. We end up with some insane number of tags, right? Because every recipe is 3, 4, 5, 6 different tags. Well, we could look at how many unique tags we have. We have 552 unique tags. That's quite a lot. What I'm going to do, and this is sometimes to save on just time and computation, but also sometimes a lot of these tags are one-off. They aren't super relevant, right? We really want the popular tags. Tags that show up in more than 10,000 recipes, let's say. And we can now see, again, the count here is just how many recipes they're showing up in. These 3 show up in almost all of them. They're sort of very general basic tags from food.com. But we'll see we can start getting a little bit more granular, even potentially some overlap with our ingredients, which we are going to have to take a look at. So we've got some tags here. We've got 80 tags that show up in more than 10,000 of our recipes. Now, this number here, why did I choose 10,000? It's a little arbitrary. I liked the number 80, as we'll see where this information ends up getting populated into. I played around with this a little bit to see what was coming up with. Right? You could change this number, and we could get a little bit more. You'll see some of these are very specific. Some of these are a little bit more general. We're also going to deal with our tags in Streamlit. Right? We're going to provide some options for a user with some of the really sort of high-level tags. I'll talk about that again when we get to Streamlit. Well, we want to do something really similar with our nutrition. We've got it as this list, really a string representation of our list of different numbers. And where I got the data from, right, which is Kaggle, which is a great place to look for data if you're just starting out, got lots of different projects and competitions, is it's in this order. We've got calories, total fat, sugar, sodium, protein, saturated fat, and total carbohydrates. And so I'm actually going to break those out into each one of their own columns. So instead of having all of that information in one column, which is a little bit hard for us to parse through and compare, right? Compare list to list. Every list is going to be slightly different. I want to compare each number to each number, right? The calories from one recipe to the calories of another recipe. Right, the protein from one recipe to the protein of another recipe. If we take a look here, I'm also just going to get rid of the nutrition column once we break it out. Right? We've got that information elsewhere. We don't need it. Again, this is going to take a second here. There we go. We'll notice we've got these columns for each one of our nutrition information. We want to do the same thing with steps as well. You'll notice a pattern here. This data came into us in a very specific format, and we need to deal with that so that we can use this. Just looking at the steps for one recipe here, we'll see they're very specific. I've got my list, right? Again, my square brackets. Very, very specific. In our case here, right, there is definitely something we could do here, but we're going to have to dip into some really heavy natural language processing, what we call NLP. This is pretty advanced. We're not going to cover that here in this demo, not at all. I know I'm glossing over a lot of things already. This is sort of the precursor to things like generative AI and large language models, like ChatGPT, Claude, Gemini, right? This idea of language processing. Can I compare different steps across all my recipes to see if there's some similarity? Well, the answer is yes, but it takes some pretty advanced code, and we're not going to touch it here. So we're just going to keep steps in that we want to return to our user the steps for the recipe. Right? Again, they're very particular. Some of these make a choice, right? Some of these are just kind of weird steps. And so we're going to be a little bit hard pressed with sort of basic Python and Pandas tools, basic data science tools to extract much information from this without dipping into some pretty heavy concepts. NLP fascinates me, not just because, right, it's sort of the building block for large language models and generative AI, but just because trying to analyze human speech is fascinating. Speech and text, right? Using both of this there. Everything from reviews, right? We could have reviews for these recipes we could do. I've done a recommendation system for books using different review data, text data. It really fascinates me. It's an ever burgeoning field. Everything from your spam filter on your email, right? What emails go into your spam folder are related to natural language processing. We're going to do our ingredients as well. Again, you'll see a trend here. And it looks like we've got some ingredient strings. This we can definitely work with. We can look at some of our more popular ingredients, not surprising. Right, some of the staples of cooking here. And I'm going to do the same thing. I'm going to filter my ingredients a little bit. I've got, almost 15,000 unique ingredients. That's quite a lot. We're going to filter it to ingredients that show up in more than 2,000 recipes. Now, there's some fudging we're going to do with our ingredients here. Again, this is something that we would need to dip into natural language processing to really deal with in a comprehensive manner. But right, if you check a list here, and I'll check the word chicken, right? Chicken shows up in a bunch of different ingredients: chicken broth, chicken stock, chicken breasts, chicken thighs probably show up, later down if we didn't filter it. There's probably some other, like chicken soup, can of chicken soup. I think that's in some of these recipes as well. If you ever made like green bean casserole, one of my favorites for Thanksgiving. So something to think about here, right? Do we want to standardize this? Because we could do this with some advanced NLP. Again, we're not going to touch it here, but right, do I want chicken broth and chicken breast to be the same thing? Maybe I do, maybe I don't, right? Do I want chicken breast and chicken thigh to be the same thing? Do I want chicken to match all of these different things, right? If I input chicken as an ingredient, should it match broth and breast and boneless chicken and chicken stock? We're going to go with that option here so that we're covering sort of all of our bases. But again, if we wanted to get really granular here, we'd have to dip into some heavy natural language processing. Well, now that we've explored our data a little bit, we know we want to use ingredients and we know we want to use tags. I'm going to create a little function here to split that out into its own columns. Basically what we did with the nutrition, but here we're using this filtered list we have. So I'm going to do it for my ingredients. This is going to take a second here. Bear with me. Let's let it run a little bit. Sometimes you always got to wait. When we get into, not something we'll touch here, but if you get really into data science and you get into machine learning and actually modeling, predicting, you'll be sitting there waiting for a model to train for 2 hours. It behooves you to use your time to spin up or shore up your text or go for a run, right? Use your time efficiently waiting for some of this stuff to run. You'll notice here, I'm going to run this while we look. We've got all of those filtered ingredients we have as their own columns, and if that recipe contained it, true or false, right? What we call a Boolean variable. Did this recipe contain that ingredient? And again, we looked at our filtered list of ingredients here with about 173. These are going to be the features we use for our comparison, among other things. We've got our ingredients, we've got our tags, right? Our 80 different columns. Same thing here, Boolean, true or false. All of our different tags. And I'm going to go ahead and combine these two using some pandas. All right, we've got 2 data frames. We can shove them together, all based on our what we call the index here. Well, now I've got my tags and my ingredients together. We're getting closer, but there's some other information I want to add. I'm going to go back to my main data frame, and I'm going to drop most of that information. I don't really think the number of steps is going to be important for comparing recipes because these steps are so different, right? One recipe with 5 steps might be very different than a different recipe with 5 steps. Right? They might be very different steps, very different time constraints. We're also not going to include minutes. I tested this out a little bit, didn't do much for the comparison. Again, right, just because something takes the same amount of time to cook doesn't mean it's the same at all. And same thing with the number of ingredients. So you see, I brought in my nutrition information. That's what I really wanted, because that can really help us compare recipes, right? Similar recipes you can think of as maybe having similar nutritional content, or at least some people, right? That's important. So we want to include that in what we're going to call our features here. Now, if you've noticed, when we look at our tags and our ingredients, there might be some overlap, right? Some of our tags are just ingredients, only a few of them, but some of them. So I need to check that. What I'm doing here is checking if I have duplicate column names. And in fact, I do. Looks like sugar was a tag and an ingredient. Chicken was a tag and an ingredient. I know poultry is also a tag. It's kind of interesting. Cheese, again, was a double one. Same with potatoes. Only 4. Pretty good. We want to deal with that. Again, just another sanity check. There's those 4. Value counts is going to be your best friend when we think about counting up different categories. I'm going to go ahead and get rid of those. I'm not going to harp too much on the code here. I'm keeping everything that's not duplicated. We're now going to save this file off. We've done what we need to. We need to use it elsewhere potentially. I'm going to go ahead and save it. It's going to create it. These files I have also already provided in the repo. If you can't run this notebook, we're going to use these in our Streamlit app. Now, I'm breaking these out into slightly different files because of file limit constraints. I have a lot of recipes, 230,000. These are very big files. I'm a little limited in terms of GitHub and what I can actually keep on GitHub. And so I'm breaking this out. I've got my tags and ingredients here, so we can search through this for recipes. I've got my features here so that we can return some similarity comparisons. And, all right, let's save this one off. I've also got my steps. Right, how we're actually going to return recipe information to our user, let's say. I've got different steps, description, and I've included some things like ingredients because we'll need to access that as well. So I've broken these out into slightly different files. Now, before we actually hop right over to Streamlit, we can do some testing because we know what we kind of want to do. I want to be able to search for different tags and different ingredients, right, and have it return me recipes that match that. And then I want to do my, right, if it matches that recipe or you like that recipe, we want to do a comparison. We want to do a comparison there to all the other recipes so that we can give you some similar recommendations. Well, I've got my tags and I have my ingredients, right, both as these list objects. For tags, really simple. We can just search and see, are the tags that you've chosen, right, are selected, and we'll talk about how we actually input that. We're going to do it with Streamlit, right? Are those tags in this tag column, right, for any of the rows, for all of our rows? What shows up there? If it matches, right, return true. Let's say we're looking for poultry and 30 minutes or less. I want to look at this. All right, we now have a match. All of these recipes had the poultry tag and the 30 minutes or less tag. So we've already narrowed it down, right? We've already sort of subsetted or filtered based on that information, what we're searching for. Well, we can do the same thing for ingredients. Let's take a look at chicken and lentils. Now I need a slightly more advanced function here. I know I'm glossing over a lot of this code. Are these methods Python or are they NumPy pandas? A bit of pandas and basic Python as well. A lot of this string method is just Python, but we're running these things on data frames. That's a really good question. So I'm using basic Python to form a function here, right? Define my function, ingredient, check ingredients df. Again, we're using basic string Python here, some lowering like roller casing. We're using some for looping. This is basic Python. But what we're going to do is actually apply that to a data frame. So recipes test is our pandas data frame, our data. And I'm actually applying this function across all of my rows. This is how I can take, right, one function, look through the row, and look through the ingredients in that row and see if it matches what we've selected. But we want to do that for all 230,000 recipes. Well, doing that manually, right, that would take me ages. I would be here till I was 50. Well, we can apply this function. So this is using pandas in tandem with basic Python, what they're developed for, to really, really, really improve our efficiency here. We can take this. Oh, I need to run my function first. There we go. Right, this is telling me that this is not defined because I didn't run the above. And now we see that we're actually only left with 4. We're left with 4 recipes here that match both our tags, poultry in 30 minutes or less, and our chicken and lentils. And we've got the tags and the ingredients, and we have an ID, which means we can connect this to some of our other information, right? Maybe our steps. We can connect it back here using this ID, and I can get the name, I can get a description, and I can get out the actual steps for it. Let's choose ID 66735 here, right? I believe this is a red lentil recipe. Well, I can look specifically for that recipe. Let's just take a look at our steps and our name. Chicken with red lentils, and we have our list of steps. Right, very specific here. So we can extract, right, information based on a recipe that a user is interested in. I'm going to do a little bit of formatting here. This is for Streamlit. Again, we're kind of just setting ourselves up here for success. And I'm going to take the name, right, chicken with red lentils, and replace all the spaces, right, empty white space with a dash. Chicken dash with, right, lentils. This is because the company, the website that I've grabbed these recipes from, or that these recipes were grabbed from, I did not actually grab these myself, follows a very similar pattern, or the same pattern for all of its recipes. It's the name separated by dashes and then the recipe number. I can actually go to food.com, and here is that chicken with red lentils recipe. We can provide this link to our user via the app, right? Even better, because note that our ingredients didn't really come with numbers. That's one of the big downsides I found with the data I've got here. It's a little bit harder to pull this number and associate it with the right ingredient. Looks like they were pulling just the blue when this was called scraped, right? This data was grabbed from food.com. Oh, you probably can't see what I'm showing you. Really quick here. Let's just show you. Right, it brought up the recipe. Red chicken with red lentils right here. Food.com. Apologies there. I'm going to hop back to my notebook. So we can get the actual link. That's really good. We're going to want to we're going to give that to our user, right? We want to display the link to them. The more information, the better it is, right? The easier it is for the user, the more they're going to like it. And then finally, before we hop over, let's think about our actual recommendations. Let's say you really liked this chicken with red lentils recipe, number 66735. Well, we can find similar recipes to that in our existing, right, out of our 230,000 recipes. I can isolate that one, do a little reshaping so we can use it, and I'm throwing it into my cosine similarity, right? We're comparing the angle for this one recipe vector, right? Our chicken with red lentils represented as its nutritional information, its tags, right, and its ingredients in that features data frame we looked at, compared to all the other recipes in that data set. Right? Let's get out a similarity score. The higher, the better. The higher, the more similar. We can group those together, right, with the actual IDs. We can sort it by high to low, and then we can return the highest scores. Now, notice that I'll run this, and I'm only returning the second highest. I'm returning 5 scores here, from the second to the 6th. Because the first score is itself, right? It's going to be essentially, right, perfectly similar to itself. There's our chicken with red lentils, right? That's the actual recipe. We don't want that in there. We could adjust this number. I'm going to stick with just 5 recommendations here. But it's really easy to get content comparisons, like really easy. If you think about Netflix, right? You watch this, so you're probably going to watch that. It seems like there's some crazy algorithm going on there, and there is, but really it's just comparison, right? This TV show is a certain genre with a certain actors, right? Or actresses and writers with a certain theme, with a certain scope, with a certain number of episodes, right? A certain style. Well, here's another show that's very similar to that, right? Based on that information, we think you're probably going to like it because you liked the other one. So ultimately, when you think about recommendation systems in terms of a content system, it's a pretty simple comparison when you really break it down. Now, what they're using as features, right? Netflix isn't going to tell you that because that's their moneymaker, right? That's totally proprietary to them. They're protecting that information as they should. But that's where the really sort of the advanced stuff goes, right? What are they using for features? Did they do some NLP with reviews? Did they break out different genres, or did they keep them as multi-genre? And so you can get really fancy when you think about what features you want to use in your comparison. The comparison itself, right? We're just looking at two vectors and seeing how close they are. If you think about a single row, and sorry for the scrolling here, right? A single row here being a vector. Again, all of that information about that one recipe. So now that we've got some of this stuff in place, we are going to hop over to a Python file. I'm just going to come up here and create a new file in this location. Let's call it recipe rec or recipe search.py. I want a Python file. And you'll notice I've got a blank file here. This is the start to our Streamlit app. Streamlit's going to run off Python. All we need to do really is put the code in here that we want Streamlit to display and utilize some of the stuff we've already just done, right? We're going to pull a lot of information from the data cleaning notebook. This is why we did it there first, to sort of test it out and trial it. But now we're going to put it into a Python file here and utilize Streamlit. Now, what I want to do, I'm going to share a second window with you, is I'm coming into my terminal where I first started, and I'm calling Streamlit run on this file we just created. And I'm going to share this with you in just a second. What this does is this runs this Python file as we would run it if it was a live web app, what that page is going to look like. So we can actually code essentially in real time. You should be able to see both screens. Someone please let me know if you can't. On my left side here, right, sort of in dark, and I'm going to move my Zoom windows here so I can see it myself. We've got what that web page is going to look like. Notice I'm locally hosting this, right? So this isn't actually deployed yet, but we've got the web page up over here. I'm going to bring up, sorry, let me move one more thing. Too many windows open, as always. Continual problem for coders and programmers, data scientists. I've now got a blank web page. Right? You notice I can link into Streamlit itself. I've got some options here. I can think about deploying it there. There's nothing here because we've written nothing in our Python file on the right. I really love Streamlit because of this sort of synchronous nature. There are some other similar programs or applications, whatever you want to think of Streamlit as, a company that do this. I think Streamlit does it really well, and they're continually improving. Well, we need imports as well. I'm going to import Streamlit. Okay, let me do this. Sorry, y'all. I forgot to do this. I'm going to turn off my Copilot. That's some generative AI that we don't need right now because it's just going to get in my way. I know what I'm typing and I know what I'm coding. Sometimes. We need to import things we're going to use. We need pandas. We need Streamlit. I thought I just turned that off. Okay. And we need our cosine similarity. Metrics, pairwise cosine similarity. And it's prompting me tab completing, really nice. One of the benefits of using what we call an integrated development environment, an IDE. VSCode in this case is a Microsoft product. Not that I'm sponsored, but I highly recommend VSCode. There are lots of other good IUDs out there, right? This is just the one I'm probably the most familiar with at this stage. So I still need imports, just like we did in our notebook. And I need to load in my data. Now, with Streamlit, I'm going to do something a little fancy. Anytime I want to use something with Streamlit, we call to the package st. Right? I imported Streamlit as st. And I want to actually cache my data. This is to save a little bit on memory. Again, we're using a free tier of Streamlit here, and I need to save on some memory constraints. By caching my data, and I'm going to define a function to load data. I need to click back in here. Using pandas, we're just going to load in our files. And I'm going to write this a little bit differently. We're going to make this dynamic. And we want to turn is a Parquet file with the path. Parquet is just a fancier compression on a CSV file. Makes it smaller. Again, I had some memory constraints here with GitHub. Can't have anything on a repo that's over 100 megabytes, single file-wise. Parquets are smaller files, which is nice. So we need to specifically read that in. Now this is going to, again, right, cache my files. So I only need to really load them in once. And I'm going to load in we look at the data, the files we created, right? Recipes, ingredient tags. We're going to do the same thing for steps. And we're going to do the same thing for what we'll call our features. I've now got my data loaded in, and nothing's happened over here, right? I can hit rerun, and nothing's over here. You'll see it's loading data, but we haven't actually told it to display anything. This is where Streamlit and what they call widgets come into play. We can do a lot of things with Streamlit. I'm not going to highlight all of them. They have really great documentation if you're interested in. And Streamlit's not just data science, but for any kind of, if you want to create any kind of application, right? Let's say you want some live website for, keeping your family game statistics, right? You've got an intense rivalry going. We can call to Streamlit with st. And I can do things like put in a title. I can put in subheaders. We're going to call this, let's say, content, recipe, search, and recommendations with an S. Now, if I come back over here and it's going to rerun for me, all of a sudden, boom, perfect. I've got my title. We can start populating what our web page will look like, right? What our app will look like via this Python file. And we can do this, right, basically in real time. I could display an image here. I don't have an image to display for us, but right, we could do that as well. Actually, we do. I was smart. I put one in here. Okay, let's do that. Let's do it in front of our title. Note that this is going to be sequential. We've got images, and I've got header.jpg. All right, I put that in front of my title, which means my image should show up before it here in Streamlit. Beautiful. But we can start populating this. Now, I'm going to start pulling in some code from elsewhere. Chat there. Yeah, okay. We need to think about our tags. We've got all these tags. We want to give our user a chance to select them. Now, we have a lot of tags. I don't want to just give all of those options, right? That would be kind of overwhelming, especially in my opinion. I've gone and chosen some of the important ones. Some very high-level tags here. 60 minutes or less, 30 or 15, meat, poultry, vegetables, or fruit, or pasta, rice, grains, some dietary or healthy options, low carb, low sodium, and then some beginner and sweet and savory, right? Some of the two biggest categories. So we now have some very good tags, right? High level categories that we can have a user select. I'm storing this as an option list here. And we can actually use Streamlit to ask for that input, right? We need the user to interact with that. So I'm going to create a variable that represents what the user has chosen. And I'm going to use Streamlit to form a multi-select, right? Streamlit has text input, number input, single select, right? Slide bars, different radio buttons. In this case, we're going to get a drop-down selection based on this list of options. So if I come back over here, it's going to ask, right, please select any tags for a meal you're interested in. And we'll see we now have this option, right, to choose the different tags that we are interested in for a recipe. Well, okay, we've got our tags. That's good. Let's consider bringing in our, I'm going to jump over here, our tag function, right? We need to check. Again, this is one of the reasons we tested this out in the notebook first before we come over to Streamlit. A little bit harder in just a straight Python file to run code line by line. You could do it, but it's much easier via that notebook format. So we've got our function here for tags. We can think about what we want to do. Well, if we've selected tags, we want to apply this function. Now, we're going to hold off on that for a second. But right, that's kind of what we're going to do, right? Once someone's selected tags, we want to then search through using this function we've created to find all the recipes that match those tags. Okay, well, we also want to do this with ingredients. So let's think about our ingredient input. Now here, right, we have a little bit more flexibility, maybe is the word. And I'll pop this over here. We're going to use a text input just so we can see. Right, and we're just going to ask the user to enter any ingredients they have on hand and separate each one by a comma if they're entering multiple ingredients. And we can actually provide a little help box. We want them to be lowercase and when appropriate using plural. This is just to help align with the data we have. We could deal with it on the back end, but so we have a way for a user to enter ingredients. Now, this I want to be a little bit more open-ended than the tags, right? I also don't want to just provide a list of all of my ingredients because we have a lot of ingredients. That would be too long of a dropdown, but we do want to give the user some options here. What ingredients do they have? What ingredients do they want to make a meal with? And we can provide that options. I do need to split this by a comma because that's how we're entering it. This is going to give me a list so that I can use it in that function we created. So now that we have our ingredients in, we can jump over and grab our ingredient check function as well. And we're just going to pull that in here. We don't need to change anything, I don't think. We've got our row. So this is going to be, right, the actual ingredients that the recipe has. We're going to join that all together into one big string. And then we're going to check, right? Are any of the items in our list of selected ingredients, right, that the user has inputted, do any of those items show up in this long list or this long string of ingredients, right? In fact, we want all of them to show up. Hence, right, if it doesn't, we'll return false. Only if all of them show up do we return true. Well, we now have our check ingredients. We can now think about our actual search. I've got my tags, and just to hop over here, right? It already did it kind of for me, but right, we can enter whatever we want here. We've got our tags and our ingredients. We can think about creating our search. And I'm going to put this behind a button in Streamlit. Again, Streamlit's got lots of different inputs, lots of different ways for a user to interact. we've got streamlit.button. And we're going to call it search, right? Search for matching recipe. That's what's going to show up on the button when we see it over here on the left. Well, if that button is clicked, right? If someone interacts with that button, we're going to go ahead and make a copy of one of our data frames, the ingredient tag one. This is just so that we don't have to keep loading in this. One of the reasons we cache this file is it's a pretty large file. I don't want to keep loading it in. So I'm going to make a copy of it, manipulate that copy every time we go to do a search, right? So that I'm keeping that main version so that we can, right, keep making a new copy of it without having to reload it in. Well, if we've selected tags, right, I want a user to be able to just search for tags and recipes without any ingredient input, or ingredients and tags, or just ingredients and no tags. Hence, we're nesting these in our if statements, right? If they've selected any tags, we're going to apply that function, create our tag match column, and subset to only recipes, right, where that column is true, where all of those tags have matched. Right? All the tags you inputted, all of these recipes have those correct tags. We're then going to do the same thing for our ingredients. If ingredients selected, right, we're going to apply our function and do some subsetting. Right? Continuing on, if we've selected tags, right, this is already going to be subsetted, and we're subsetting it twice. This is now everything that contains those tags and those ingredients. I can pull out the ID values. I can go through my steps data frame and grab all of those IDs, right? All the recipes that match the IDs returned to us from this process. And we can spit out just the ID, name, and description, right? We want to keep the return a little simple here. And we're going to use .write, streamlit.write, which is the magic command here. This will display almost anything. The Swiss Army knife of Streamlit commands. This is from their own documentation. It'll display figures, right? It'll display graphs. It'll display data frames, in this case. It'll display lists, right? Numbers, text, markdown. You can write HTML, right? It will pretty much display anything outside of some constraints. Well, we should now be able to have our search for matching recipes. So let's look at 30 minutes or less poultry and chicken and lentils. So let's look at the one we looked at previously. I can search for matching recipes. We're going to give it a second to think, pretty quick, and we get some recipes that match here. In case we get 4 here, right? Some Balti chicken, some chicken with red lentils, some chicken tagine, and some Saudi chicken with lentil stew, gluten-free. Oh, let's look for something else, right? Might as well. Let's look for some vegetables, pasta, grains. Don't really care what meat. Let's say I want carrots, maybe some onions, and maybe some garlic. Enter those in, search for some recipes. And we get a lot more options, right? Lentils are maybe a little sparse. I love lentils, I agree with that, but maybe not used in a lot of cuisine. But we get a lot of recipes here, a lot of options, right? Lots of good stuff with the description we can click into and see. Let's say one of these recipes caught your eye. Well, we can take this a step further, right? Because this is great, but now they got to go search for that recipe, right? Okay. Well, we can think about another button with some more interaction here. This needs to be like that. Indentation is really important with Python. I'm going to ask the user, right? Does one of these recipes catch their eye? If so, enter the ID number. Right? Are you interested in this recipe? Take a look at it. Well, let's create a button, right? Get that recipe, right? Enter the number, and you can get out that recipe. And so if that button is clicked, right, we're going to pull the ID number that they selected to find the recipe. We're going to pull out the name and the steps. And we're going to look at our ingredients. We can do our little link here, just like we did in the notebook. And then we can write out, right, st.write, all of that information so that we can display it. We can actually count up the steps, right, for step in steps, just add a 1 every time, step 1, step 2, step 3, so that we can display this. We've now got, let's search for some recipes. Let's say I really wanted beef chop suey, right, number 107. We could use the name, but right, the number here is probably a little easier to enter without misspelling, and we could go ahead and get that recipe. We've got the link, right? We're creating our link here and displaying it. If you do have questions, I see your hand up there, Peter. Go ahead and throw it into either chat or just the Q&A. Chat still isn't accessible. You know, Patricia's running the Q&A, but go ahead and throw it in there. I've got that open. We'll take questions at the end too as well, but you're happy to put it in there and I can take a look. So we now got all of the ingredients, right? We have our different steps. We have the actual link to what is beef chop suey here. Right, and we get the full recipe out. Too many windows. There we go. And we could do this, right? We could look at some more recipes. Maybe, okay, maybe I don't want chop suey. Change my mind. Takes too long to make. Let's go with 30-minute minestrone. That's a little simpler. 29453. We can go ahead and get that recipe as well. Serve immediately. Perfect. This is easy. 30 minutes. 30-minute minestrone. It's even in the name. Submitted. Okay. So we can jump through, right, all 230,000 of those recipes, theoretically, right? If we chose nothing to match, it should theoretically come up with all of those. Now, the last thing to think about here is this recommendation. And we are going to code this up in Streamlit here. The one issue, oh, I don't want that. The one issue is that it's very memory intensive. And so if we use this when it's actually deployed, right, if Streamlit is actually deployed, it doesn't quite work in the sense that we run out of memory. It's very memory intensive because of this similarity, right? I have to compare one recipe to 230,000 other rows, right? That is very computationally expensive. Now, the step above, right? The next step, how do I solve that? Because that's a problem, right? Would be to use a third-party database. Any number of companies, Amazon, right? Microsoft Azure, there's some smaller companies out there as well that I'd probably go with, something like Redis, because we're storing vectors here as a vector database. I could store that information, right? I could store my data sets. I could store this comparison. I could do a full similarity comparison, right? All recipes to all other recipes. And I could store that information elsewhere, right? Probably have to pay for it, right? Always, always, always. You're using someone else's computation, right? The cloud, you got to pay for it. But I could keep that elsewhere. And then Streamlit has some ways to interact with that. They have a database widget, right? We could call to the database so that it's not being hosted by Streamlit. We don't run into those memory problems. Again, that costs money. Always, 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 always. So I haven't done it here, but that would be my solution. So I do have a way around it. Just not something we can implement here, right? Using another tool, using another third party to help us deal with that. We need access to, right, a place to store information, basically. Well, I put in our similarity here, right? Just pulled this from the notebook. If you liked this recipe we returned to you, right? You got that recipe and you liked it. Well, maybe you want to look at some similar recipes, right? Again, our similarity comparison. We can code that up here. If we take a look, we'll get one more step. Right, let's search, let's add some chicken in here, why not? Let's search for matching. We got 610, 607, cool, 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 okay. We got a different kind of minestrone, interesting. The bomb pumpkin soup, that sounds pretty good. Let's go with the bomb pumpkin soup. And note that the way I dealt with ingredients here, right? Chicken can equate to anything from chicken breast to chicken broth, probably why something like that soup is showing up here, even if it might not have, right, actually chicken in it, it's using chicken stock. Now, I did that on purpose here. Maybe not ideal, maybe it's what you want. In this case, I think I kind of did. If we really wanted to get super granular with our ingredients, we would probably have to step in again to some heavier natural language processing. We could even make the leap into using some LLMs. Probably go-to would be using something from Hugging Face, which is a really good place that sort of hosts these models. But they have some really good text encoders, specifically something called BERT, but there's some other ones as well that work really well with text, right? Pulling out encodings. What we mean by that is like each ingredient would be represented as, right, an encoding, and it could therefore equate, anytime it sees chicken with these other ones, or maybe, right, specifically with chicken stock, chicken with chicken, chicken breast with chicken breast. But then the users got to get really granular. So we've kept it pretty broad here in this case. So that is really high level, right? Streamlit. We can do a lot more here. Just showcasing some of the very basic widgets. Again, we have ways to input lots of information. We have sliders, we have buttons, we have different select boxes. You can type in text, you can type in numbers, you can actually upload files, you can have it take a picture using someone's webcam. Excuse me, sorry, apologies. Maybe you were doing a facial recognition model, right, deep into some machine learning and some TensorFlow, into some really deep convolutional networks. And you wanted to do some facial recognition, right? And you wanted to have your user be able to put in their face. So we can input any number of things into Streamlit. We can display any number of things. We can do a lot of visualizations here. That's the big thing I didn't touch on. That's really crucial for data science. As part of the EDA, part of the ETL generally is, right, some graphs, some visuals. Show, don't tell. What's your data doing? What does its distribution look like? We're dealing with a lot of text here, so not as big of a case for that, but also a huge part of data science that we didn't quite touch on. Well, you can display any of that stuff in Streamlit. Streamlit can display what's called matplotlib figures. That's one of the more common libraries. It's like the pandas of visualization. You can visualize with pandas itself. You can do something called Seaborn. You could do Plotly, which is a little bit more interactive. GraphViz, again, a little bit more interactive. So they have a lot of good tools and functionalities to handle, right, all these different ways you might produce information, visual content, numbers, right, returning our matching recipes. We could, instead of returning as a data frame, right, we could like write out all of those names, kind of like we're doing for the name and recipe for the single one. So lots and lots of capability here. Now, the last thing I'm going to attempt to do is deploy this. And I say attempt because sometimes this can have some hiccups. I've tried to set up everything so it doesn't, but give me 1 second here. What I need to do, right? We've created this file here that is running locally our app, right? Our Streamlit app. Well, I need to get this back to GitHub, its original place, which is why I have that template available. I'm going to do that via my terminal. I know we hadn't talked about Git too much at all, so no worries if you're not comfortable there. I am going to, I'll keep that up for us, might as well. All I'm doing is, right, we edited this file here, recipe search.py, and I'm going to add and commit this to GitHub, if you know what that is. We also changed data cleaning a little bit. Not that that matters for Streamlit. Right, Streamlit really just cares about the requirements, which we have that, the text file, and, right, this Python file here. If it needs the data, right, it needs the data. We have to have those data files, hence what we created in that notebook and the image. But really, this is what the file it's running off of. So I'm going to put these up to GitHub. If I can type, you can't see what I'm doing. Give me 1 second. Okay. Oh. not need to do that. Let me bring it up for you. Okay. Well, if we take a look, I need to go to, hold on, y'all. Here we go. This is just my version of it. You'll notice that I now have this recipe search.py file here, which is what we need, as well as the requirements. I'm hopping back over here. I will try and leave this going, but we want to think about deploying Streamlit Cloud. It's going to connect to my repo. I logged in with my GitHub account. Again, this connects to GitHub. It's how Streamlit does this interaction. There are some other ones, but mostly GitHub. So you got to log in with your GitHub. Your GitHub account is free, right? Streamlit account, free. There's no credit cards here. There's no nothing, no free credits, right? But that does leave us with some memory constraints. Notice that I'm giving it, right, the repo itself, the file that's going to be our main system, and we can provide a name. Let's just do recipe search. It's like it's available. We want to change to the newest version of Python, which is what we're running. And we can try to deploy this. This is our last step here. Thank you all for patience. Let's see if it's going to behave. Our app is in the oven. That's a good sign. We can see that the first thing it's doing is thinking about that requirements, right? Provisioning the system, spinning up basically a virtual machine. And it's going to start to try to download from that requirements.txt file. And this is why it's really important to think about this when you're starting out a project. Looks like it worked. Beautiful, beautiful, beautiful. You were going. Let's come on, come on, come on. And there we have it. Now I've got right managed because I am the admin here, but y'all should be able to hop in here. Now, if we do this one, I'm going to click it. It's going to break it. So this will break in just a second. This is that memory constraint I was telling you about. But I can go through and select. Let's say we want chicken and lentils again. I was just really feeling lentils when I was doing examples here. I can't tell you why. I do really like them. We could get out some matching recipes. We've got our, let's look at the Tianjin now. Was it 287439? And we could get that recipe. And you all are welcome to try out, look at some recipes here. Again, this is live. And this is a web address that you can share it out to people. Copy the link. We can click into our actual website here with the recipe. Perfect. We got the right one. And again, this is the button that's going to break everything. We're going to run out of memory. It sends me an email every time it does this. I tried to do a little bit ahead of time to save on memory. Wasn't able to get there. Again, I think my better solution would be to step to some kind of database. And apologies there, Levi, I see your question. How is Streamlit accessing the project directory? Yeah, via GitHub. It has a very good connection. Relationship maybe isn't the right word. I don't think there's any money changing hands, but right, we provide that image in the repository, we provide those data files in the repository, we provide that Python file in the repository, and then we can just connect that full repository, as long as it's public, to Streamlit. I think you can deal with some private repositories. I haven't dealt with that myself. Streamlit does also let you put in like keys, secret information, so that it's protected. So if you were calling to an API somewhere, right, you're calling to Spotify's API because you wanted to grab, the top 10 songs from yesterday. Just you want to do that every day for some reason. I don't know why. You could probably look at Streamlit, or you could probably look at Spotify, but you could pull that information. You need to have a private key, right? A private access associated with Spotify. You could provide that to Streamlit when you deploy the app. If you notice, when I went into advanced settings, it had a secrets option. And so you could hide that information from your users, right? So that they can't use it maliciously, because that is essentially your personal password, right? They call them access tokens or keys. OpenAI, right? When you're calling to large language models and you're paying for tokens, you have a similar thing. You don't want everyone to have access to that so that they can misuse it, and all of a sudden you have a $3,000 bill, God forbid. So you can hide that stuff. But yeah, Git is really awesome in this sense, not just for project storage and for having a place to showcase this, but because it connects with things like Streamlit here. So we're now live. Again, I'm going to go ahead and try this out. And it's probably going to tell me, oh no. It might work once. Yeah, okay. Immediately connecting. We ran out of memory, right? This similarity comparison is very intensive. I would need to step to some other ways to host that data. I could obviously reboot this so that we can get back to looking at some recipe searches. I knew this was going to happen. It's expected. It is free, right? There's always limitations when things are free. They're working to get some tiered paid stuff. I'm not sure timeline on there. Again, I'm not affiliated with Streamlit at all. Streamlit, if you've heard of a company called Snowflake, they're sort of a database, data lakehouse, data warehousing. They're trying to become a bit like some of those other companies that exist, AWS, Oracle, etc. They've actually purchased Streamlit, I think within the last year, 6 months. And it's gotten better and better. Again, they've added more and more content. They have a way so you can create multiple pages to your web page. You'd create a folder with different Python files in it, and you'd actually have a different click down menu. So you could go to different pages and they're actually run on different files, which is really nice. So they've been added in a lot of functionality over the last 6 months because they're now connected to a larger company, right? They probably have more funding. They have more hands on deck, right? More people, more developers, which is just bodes well for the future, right? I like Snowflake as a company from a data standpoint, right? From hosting data. Well, you could probably pay them to host some of this larger data. So those are really good signs in terms of the life and the things you might expect to be updated within Streamlit. They're also really good at responding to requests. I had a big problem with my account because my GitHub is connected to some admin accounts, Flatiron. Owner isn't the right word, but I'm an administrator on some educational accounts within Flatiron, and Streamlit was having a hard time divesting that from my personal repositories. And I just sent their tech support a note, and it's something that they were aware of, and they actually spun out a fix for within a month, or the last month. So I'm no longer getting this login trouble. I had to keep refreshing, and it would take me 5 times to log in, but they fixed it. So again, just want to highlight that they're actively working on things, which some things might not be actively being worked on. Okay. Let's see. Answer that one. That's what I've got for y'all today. Again, you're welcome to, I'll post this again here. Hop out, try some recipes. Shout out to lentils. I'm making some lentils tonight now. I have to. There are a lot of things we could do to improve this. I'll end there, right? We could definitely step into some database to house our information so that we can get that true similarity working. We could definitely do some NLP, some language processing, to dive a little deeper into not just the ingredients, right? The difference between chicken and chicken breast, et cetera, but also into the steps themselves. That's really where I would like to explore, right? Can we compare recipes based on similar cooking steps, right? Maybe you like this recipe because it was easy to cook. or you really like souffling things, or you really like grilling things, right? That might be a tag as well, but that's going to be in the steps. We're going to need to use some language processing to actually tease out and extract that information. So that's definitely somewhere where I would go next. Again, that gets even into maybe using some generative AI, some large language models to help with that process. We could also think about doing more deeper recommendations. Right, I mentioned that this is what we call content recommendation system. Right, it's based on the content of the recipe, which here we defined as, right, the nutritional value, some of those tags, and then some of the ingredients, right, the more popular ingredients. Well, we could include review text as part of that content, right? Again, some NLP. We could get into different reviews. We have that data available via Kaggle. We could weight some of these recommendations by the popularity or the rating of a recipe, right? These, we're going to rate your recommendations or weight your recommendations because these are really popular recipes. So we think you'll probably like them if a lot of other people like them. But we could also do the collaborative filtering that I talked about at the beginning, really, really, really early on. Right? We could compare myself to Patricia, right? I liked certain recipes and I rated them a certain way. And Patricia liked certain recipes and rated them a certain way. Well, let's say there's some crossover there, right? We both liked 3 or 4 of these recipes and had similar ratings. But she rated some things I didn't rate, and I rated some things she didn't rate. Well, maybe we're really similar as users, right, in how we rate things and what we like. And so it's going to recommend to me things that Patricia likes and vice versa. Now it does that right across all of the users in your system. The problem there is you've got to have users. If the user isn't interacting with your system, if they ain't rating things, then they don't get good recommendations back. This is called the cold start problem. If you sign up for Netflix, what's the first thing Netflix does? Right? They ask you, what of these movies or TV shows have you watched and what did you like? Right? Give a 5-star rating. They're prompting you for that information so that they can incorporate you into their collaborative recommendation system so that they can do their jazz and you can watch, Supernatural nonstop for 10 hours. Raise your hand if you've ever been guilty of that. And so they have to get user information. Well, they prompt you for that, right? All they do is ask. And if you want to interact with it, right, you're going to get good recommendations back. My one big advice, if you're really upset at the recommendations you're getting from Netflix, from Amazon, right, from Kindle, which is Amazon, to your news, right, Google News or whatever news aggregate you're using, if you're not happy with that, try interacting with the system a little bit more. Now, it feels a little wrong, right? Give them more data. We'll get into data privacy laws and data ethics, right? Not something to talk about here. But the more you interact with that, right, the more you rate things and the more true you are with your ratings, right? I did like this, I'm going to rate it a 5. I didn't like this, I'm going to rate it a 1. The more granular you are there, the better those systems are going to interact with you. The big problem in recommendation systems is the users who just rate everything as a 5 or everything as a 1, right? If you tell Netflix that you liked everything that you watched, just rate it as a 5, it's going to have a really hard time recommending things to you because you don't have a taste profile. You like everything, or you don't like anything, and it's still going to sort of opposite direction, but it's going to struggle to recommend things to you because, right, you haven't given it any preference. And so just think about that next time you're interacting with a review or a rating or a recommendation, right? If you've got an account or some kind of profile, think about how interacting with that might help you get out better recommendations. Cool, cool, cool. Like I said, we'll end there. I could talk all day on my soapbox. It's what I do for a living. But if you do have any questions, please throw them into the Q&A there. I'm happy to answer. Again, just thank you all for joining and listening.
And in case there's no additional questions, just wanted to piggyback and just say thank you so much for joining us today. I hope that you enjoyed this workshop and that you guys were able to build this recommendation system alongside with Daniel. I encourage you to look out for future workshops. We're going to have additional intro to data science or intro to coding workshops. We actually have an intro to coding or coding for beginners next week on July 24th. So if you are interested in those type of events, please check out flatironschool.com/events. We would love to see you there. I've dropped in the chat, which again, our apologies for not being able to use it today. This link, please provide any feedback about this event. If you enjoy this event, if there was something that you would like to change, please let us know. We love your feedback and we definitely want to incorporate any thoughts that you guys may have in our future workshops. So if you guys don't have any questions, there is a question. Yes, there will be a recording for this event. For anyone that has attended, you should receive a follow-up email in the next couple of days, and that will include the event recording. If for any reason you do not receive it, I encourage you to check out our YouTube channel. Any of our events are posted there.
Final plug, gotta plug Flatiron. If this stuff interests you at all, these are big concepts we talk about in the data science course. Even if you just want to sort of hop in and see what it looks like, take a look at the Flatiron website. They have some good links to sort of free things you can do to try out Python, test out Python. That coding demonstration coming up next week would be great as well. Well, always excited to see people interested. Also LinkedIn, feel free to shoot me a connection, shoot Patricia a connection, shoot Flatiron a connection. We are super active on LinkedIn as well as some other social media. So absolutely just send me some questions. I'm happy to answer things, happy to talk about the program or just Python, coding, data science, any of that jazz in general.
Any of it. I'm just dropping your LinkedIn right now. Please connect. And find me as well, Patricia Rodriguez. You will find me. If there's no additional questions, I guess we can wrap it up here. Again, there will be an event recording available. And thank you so much for joining us this afternoon. I hope you guys had fun.